Velocity. What is velocity? Displacement per unit time interval is called velocity. So we are writing displacement per unit time interval. Displacement per unit time interval is called velocity, and we can write this equation also. V is equal to displacement by time. V is equal to displacement by time. V is equal to, here V is nothing but a displacement velocity and displacement by time. So V is equal to, you can write S divided by time. S simply I am giving as a displacement, time is a T. We can write this, we can define this definition in another way also. A rate of change of displacement is called velocity. A rate of change of velocity, so rate of change of displacement, rate of change of displacement is called velocity, So in two ways you can write here. Velocity is nothing but a displacement per unit time interval is called velocity. Rate of change of displacement is called velocity. And what are the units? Here units is nothing but a displacement, units are meter. Displacement is nothing but a length. So how you can measure the length? In meters, centimeters, kilometers. So now I am writing it is the meter, time is the second. So meter per second, it is the SI system. Units, SI units of the velocity is nothing but a meter per second. And CGS system, displacement unit is centimeter, time unit is second. So it is the CGS system. CGS units of the velocity is centimeter per second. Now we are writing it is, what is the quantity? It is the vector quantity or scalar quantity. Now displacement is the vector quantity, time is the scalar quantity. So vector divided by scalar is nothing but resultant is the vector quantity. Displacement, again displacement is the vector quantity, time is the scalar quantity. Vector divided by scalar. So that is the resultant is vector. We are writing it is, that is the vector quantity. Now what is average velocity? I am writing average velocity. Average velocity. Average velocity is defined as the ratio of total displacement covered by the particle to total time taken by the particle. So we can write that equation is nothing but a total displacement covered by particle divided by total time taken by the particle. So average velocity is defined as the ratio of total time taken by total displacement covered by the particle to total time taken by the particle. So that we are calling it is average velocity. In this average velocity, how we can write the equation means, for example, object started its journey from the position of x1 at a time interval t1 and it reached the destination. The position of the destination is x2. After t2 time interval, at t2 time interval, it reached the destination. At that moment, I am writing it is total displacement covered by the particle. So total displacement from here to here means x2 minus x1, final position minus initial position, that is, so average velocity is equal to final position minus initial position divided by total time taken by the particle. Total time taken by the particle means at t2 time interval it reached the final destination. It started its journey at t1 time interval. So total time interval means final time minus initial time. Here final time is nothing but a t2, initial time is the t1. So that we can write as a t2 minus t1. Average velocity is equal to, you can write x2 minus x1 divided by t2 minus t1, isn't it? Now uniform velocity, uniform velocity. What is uniform velocity? Uniform velocity is nothing but a, we know what is velocity. Velocity is the displacement per unit time interval. Displacement per unit time interval is called velocity. Uniform velocity means equal displacement covered in an equal interval of the time. Equal displacement covered in an equal interval of the time. However, maybe short interval of the time is called uniform velocity. Once again, I am defining this definition. Equal displacement covered in an equal interval of the time. However, maybe short interval of the time is called uniform velocity. See here, equal, unequal displacements, equal displacements covered, equal displacement covered in an equal interval of time, equal interval of time. However, maybe short interval of the time, short interval of time. That is called uniform velocity. That is called uniform velocity. How you can give the example for this one means, I am telling you here, when I am explaining about the uniform speed, I use it is equal distances covered in an equal interval of the time. Here it is uniform velocity means equal displacement covered in an equal interval of the time. But I am explaining in the same way, both are in the same examples only I am taking. Along the straight line, displacement is equal to distance. Along the straight line, distance is equal to displacement. So that's why uniform speed and uniform velocity both are at the same examples. Just I am explaining the same example, isn't it? So I am writing it is, this is the point position A and this is position B and it is position C. And one more it is, for example, okay, no problem, position A to B, I am taking it is 5 kilometers displacement, 5 kilometer displacement. B to C it is 5 kilometer displacement, isn't it? Now a vehicle it is covered, it is traveling from A to B 5 kilometers in 5 seconds, 5 kilometers in 5 seconds, and B to C 5 kilometers in 5 seconds, isn't it? See in this one, according to the definition, equal displacement. See here, 5 kilometers, A to B distance is, displacement is 5 kilometers, B to C is the 5 kilometers. So these are equal displacement. And next one, in an equal interval of time, 5 kilometers covered in 5 second time interval. This 5 kilometers covered in an 5 seconds interval of the time. So equal displacements covered in an equal interval of the time. However, maybe short interval of the time is called uniform velocity. Same example I taken for the uniform speed also. But in this situation I am telling you, along the straight line, distance is equal to displacement. Along the straight line, distance is equal to displacement. So that's why only I taken this example for the uniform speed and uniform velocity. Next one, we are writing non-uniform velocity. Non-uniform velocity. What definition of the non-uniform velocity is nothing but a unequal displacements covered in an equal unequal displacements covered in an equal interval of the time. interval of time are over equal displacements covered in an unequal interval of time. So non-uniform velocity is unequal displacements covered in an equal interval of the time, or equal displacements covered in an unequal interval of the time is called non-uniform velocity. This non-uniform velocity example I am taking. See here, again one vehicle, just I am taking, isn't it, from point A to point B, then point B to C. See here, A to B displacement is nothing but 5 kilometers. A to B displacement is 5 kilometers, and B to C displacement is 7 kilometers. B to C displacement is 7 kilometers. Now these are A to B 5 kilometers, B to C 7 kilometers means unequal displacements. These are unequal displacements. See, it's the definition, unequal displacements, and these 5 kilometer displacements covered in 5 seconds, 7 kilometer displacements covered in 5 seconds. Unequal displacements covered in an equal interval of the time, that is called non-uniform velocity. And next one, instantaneous velocity. What is instantaneous velocity? Instantaneous velocity Here instantaneous velocity means velocity of the particle at a particular instant. Velocity of particle at particular instant. Velocity of the particle at particular instant is called instantaneous velocity. Example, yesterday I already discussed this instantaneous speed, how we can measure by using of the speedometer, isn't it? Instantaneous speed you can measure by using of the speedometer. Same instantaneous velocity also you can measure by using of the speedometer only, but we have to give the direction. Velocity means having direction, but speed does not have the direction, because speed is the scalar quantity, velocity is the vector quantity. So what is the formula here? Limit delta t tends to 0, delta s divided by delta t is equal to, we can write dv by dt. Instantaneous velocity, limit delta t tends to 0 means, here limit delta t tends to 0 means the time interval is nearly equal to 0. So at that moment delta s divided by delta t, we can write as a dv by dt. This is instantaneous velocity. So now I discuss what is velocity. Here, what is velocity? Average velocity, uniform velocity, non-uniform velocity, instantaneous velocity. These all are nothing but a velocity only. What is instantaneous velocity, uniform velocity, non-uniform velocity? All are, it is nothing but a velocities. These velocities are having same units, same dimensional formula and same quantities. Means all are having, it is nothing but all are the vector quantity only, and all are SI unit, all units are having, it is SI units are meter per second, CJ's units are centimeter per second. And I want to tell you here dimensional quantity, dimensional formula. What is dimensional formula means? Dimensional formula means, see here, we have to write dimensional formula MLT. That quantity how many times, dimensional formula means how many times that quantity is raised. How many times that quantity is raised, it can be represented by the dimensional formula. See here, M is the mass, M is mass. So what is the mass unit is kg. Mass unit is kg. Coming to our units, in this one meter is there, second unit is there, but no kg or no gram. So mass is nothing but a 0. The quantity is not involved. So mass is 0. Next one, length. Length unit is the meter. So meter is how many times it is raised. See here, the meter it is one time it is, the power it is one time. So meter it is raised by one time. So 1 in length. Next one it is second. So this one you can write as a meter per second like this, s to the power of minus 1. So here time is involved, it is one time. So that we can write as a t to the power of minus 1. This is the dimensional formula for the velocity. This is dimensional formula for the velocity. 0 in mass, 1 in length and minus 1 in time. Acceleration. What is acceleration? What is definition of the acceleration? Again, here it is, we can define it is acceleration symbol, it is A first initially. We can write it is rate of change of velocity is called acceleration. First one it is, I am giving definition, it is rate of change of velocity. Rate of change of velocity is called acceleration. And also we can give the one more definition, change in velocity per unit time interval. Change in velocity per unit time interval is called acceleration. See here, acceleration is rate of change of velocity is called acceleration. For this one you can write the formula, it is dv by dt. It is dv by dt. And next one, change in velocity per unit time interval. Change in velocity per unit time interval means A equal to v minus u divided by t. A is equal to v minus u divided by time t, isn't it? So change in velocity per unit time interval is called acceleration. And in this, what is the acceleration units? SI units, CGS units, and what is the dimensional formula? Now I am writing SI units first. SI units means change in velocity. The resultant it is nothing but a velocity only. Change in velocity is nothing but a velocity only, resultant. How it is means, for example, in this one, V represents final velocity. V is final velocity. V is final velocity. U is initial velocity. U is initial velocity. See, for example, final velocity of the object is 5 meter per second and initially it is at rest position. So V equal to 5 meters per second, U is equal to 0. If I subtract here, V minus U is equal to 5 minus 0, that is equal to, we are writing 5 meter per second. This 5 meter per second is nothing but a velocity only. So the resultant is the velocity. V minus U is nothing but a resultant is the velocity. That velocity units are meter per second. Velocity units are meter per second divided by time. So time unit is the second. Time unit is the second. Second, if I take into the numerator, you can write m s to the power of minus 1, m s to the power of minus 1. Bases are equal, so power should be added. You can write m s to the power of minus 2. It is the SI unit of the SI unit for the acceleration. What is the CGS units? CGS units means meter means in CGS system centimeter, and second it is nothing but a second order. And what is the dimensional formula? Dimensional formula again we are writing, it is, what is dimensional formula? The quantity, how many times it raised. The quantity, how many times it raised. So m, L, T. Capital M is represents the mass, capital L represents the length, capital T represents the time. So mass unit is kg. So is there any kg unit? So there is no kg. So that's why m to the power of 0. And length unit is meter. So the meter, how many times it is raised? One time it is raised. So that is 1. And time unit is the second. Second, how many times it is? 2 times. So that is power, it is minus 2. So this is the dimensional formula for the acceleration. Dimensional formula for the acceleration. Now, what is the quantity? Now it is a vector quantity or scalar quantity. See here, change in velocity. So this velocity, numerator it is the velocity. Velocity is the vector quantity, time is the scalar quantity. Vector quantity divided by scalar quantity. I told you just before only. So vector divided by scalar is equal to vector. So acceleration is the vector quantity. Acceleration is vector quantity. Acceleration is the vector quantity, isn't it? And next one, retardation. I want to write about the retardation. What is retardation? See here, acceleration is nothing but increasing the speed. Acceleration is nothing but increasing the speed, and retardation is nothing but decreasing speed. Otherwise, decreasing the velocity. Decreasing the velocity. When decreasing velocity means the resultant we can get it is the negative. Negative acceleration is called retardation. For example, for your understanding, I will give one example here. For example, when object is, if anyone going to somewhere else, they will start by the vehicle. For example, they are going by the car. So their velocity is gradually increases because they are initially at rest position. So to go somewhere else, the vehicle speed is gradually increasing. The vehicle speed is gradually increasing. Means initially u is equal to initial velocity is 0. After t time interval, their velocity is, for example, final velocity is I am writing it is 20 kilometer per second. 20 kilometer per second. We know formula it is acceleration in how much time interval? T is equal to 5 seconds. In 5 seconds only they are covering 0 to 20 kilometer per second. So acceleration is equal to, you can write final velocity minus initial velocity. Final velocity minus initial velocity. Here final velocity is 20, initial velocity is 0, time interval it is 5. So 20 divided by 5 is equal to, we can write it is 4 kilometer per second. 4 kilometer per second. Now, if they are, while they are coming to home again, while they are coming to home, the vehicle speed is gradually decreases. When they reach the home, they are coming into the rest position. They are coming into the rest position. From maximum velocity to, they are coming into the rest position. See here, maximum velocity is the initial velocity. When it is reached the home, they are applying the more brakes, so they are coming into the rest position. So final velocity is 0. I am writing here maximum velocity, initial velocity is here 20 kilometer per second, and final velocity is 0. Final velocity is 0. In a time interval t equal to 5 seconds. In a time interval t equal to 5 seconds. See here, again we are applying the formula A equal to v minus u divided by t. What is the final velocity? Final velocity, when they reach the home, they are coming into the rest position. So final velocity of the vehicle is 0. Final velocity of the vehicle is 0. And from where to they are coming into the 0 means from the maximum velocity 20 kilometer per second velocity to they are coming into the rest position. So initial velocity is 20 kilometer per second. U is equal to 20 kilometer per second divided by time. In how many seconds they are reached? It is 5 seconds again. A equal to, we can get minus 20 divided by 5. So minus 4 kilometer per second. See here, negative acceleration we are calling it is a retardation. Negative acceleration we are calling it is a retardation. That is the definition. Negative acceleration we are calling it is a retardation. This is the retardation example and this is acceleration example. Acceleration means positive. Retardation means that is a negative acceleration. So what is the retardation definition? Negative acceleration uniform acceleration uniform acceleration What is uniform acceleration means? We have to go for the definition. Acceleration A is equal to v minus u by t. Here v minus u is nothing but a change in velocities and time interval is nothing but a t. So uniform acceleration we can define here equal change in velocities covered in an equal interval of the time, however may be short interval of the time, is called uniform acceleration. So I am writing the definition here. Equal change in velocities, equal change in velocities, equal change in velocities covered, equal change in velocities covered in an equal interval of time, in an equal interval of time, however may be short interval of time is called uniform acceleration. See here, equal change in velocities covered in an equal interval of time, however may be short interval of the time, is called uniform acceleration. For this one, I want to give one example here. From one vehicle, it is going from point A to point B, isn't it? This is point A. It is started with a velocity is, this is point A. It is started with a velocity is 5 km per hour. It is started with a 5 km per hour, and when reach the point B, and it's attain the velocity is 5 km, 10 km per hour. Then after, when it reach the point C, it attains the speed, it is 15 km per hour, isn't it? And when it reach the point D, it attains the speed, it is 20 km per hour, 20 km per hour, isn't it? 20 km per hour. Now, equal change in velocities covered in an equal interval of the time. From here to here, for example, A to B, I am taking it is 1 hour taking time, but it is a large time. For your understanding, just I am giving the example, 1 hour. A to B, it is the 1 hour. B to C is the 1 hour. C to D is the 1 hour, isn't it? 5 to 10 km per hour, it is a small interval of the, it is nothing but a 1 second, 2 second will be catch it. But just I give an example like this. See here, A to B, 5 km, initial speed is 5 km per hour and final speed is the 10 km per hour. What is the equal change in 10 minus 5? 10 minus 5 is nothing but a 5. Next, 10 minus, this is initial, this is final now. If you take the 2 points B and C, B is the initial and C is the final. 15 minus 10. 15 minus 10 is nothing but a 5 km per hour. Next, if you take the CD points, C is the initial position, D is the final position. Here final position speed is 20 km per hour. Initial is the 15 km per hour. 20 minus 15, that is the 5. So, equal change in velocities covered in an equal interval of the time. In an equal interval of the time, that is called uniform acceleration. That is called uniform acceleration. Okay, non-uniform acceleration. Non-uniform acceleration. Non-uniform acceleration. Same here. Unequal changes. Unequal change in velocities. Unequal change in velocities covered in an equal interval of time. Otherwise, or equal change in velocities covered in an unequal interval of time is called non-uniform acceleration. See here, same example, just I am drawing here. From A to B, B to C, C to D. Now the vehicle, it is started from A to B, isn't it? It is going like this with a speed, it is 5 kilometer per hour, and here it is 10 kilometer per hour, 10 kilometer per hour, and here I am taking it is 16 kilometer per hour, 16 kilometer per hour, and here it is I am taking 19 kilometer per hour. But A to B time interval it is 1 hour, B to C it is 1 hour, C to D is the 1 hour. Now when you take the A and B, B is the final, A is the initial. 10 minus 5 is the 5. 10 minus 5 is the 5 kilometer per hour. B to C if you take 16 minus 10. 16 minus 10 is nothing but a 6. It is the 6. And D minus C. 19 minus 16. It is the 3 kilometer per hour. See here? The difference here it is 5 kilometer per hour. Here it is 6 kilometer per hour. Here it is 3 kilometer per hour. Means unequal change in velocity is covered. Unequal change in velocity is covered in an equal interval of the time. In an equal interval of the time is called non-uniform acceleration. Unequal change in velocity. See here, this is 5, 6, 3. Unequal change in velocity is covered in an equal interval of time. Equal interval of time. 1 hour, 1 hour, 1 hour. Equal interval of the time. That is called non-uniform acceleration. And next one, instantaneous acceleration. We can discuss about instantaneous acceleration. Instantaneous acceleration. What is instantaneous acceleration? See here, what is instantaneous speed, what is instantaneous velocity? Same like that only. Instantaneous speed means speed of the particle at a particular instant is called instantaneous speed. What is instantaneous velocity? Velocity of the particle at a particular instant. And what about the instantaneous acceleration means acceleration of the particle, acceleration of particle at a particular instant is called instantaneous acceleration. Acceleration of the particle at a particular instant is called instantaneous acceleration. Instantaneous acceleration formula is limit delta t tends to 0, delta v divided by delta t. At that moment you can write dv by dt. Limit delta t tends to 0, delta v divided by delta t is equal to dv by dt. This is instantaneous acceleration, and this instantaneous acceleration, non-uniform acceleration, uniform acceleration, retardation, isn't it, acceleration, these all are having it is the same units, same dimensional formula, same quantity, isn't it? Same units means all are having it is meter per second square, and CGS units are centimeter per second square, and it is the quantity, it is vector quantity, all are it is the vector quantities only, and all are having is the same dimensional formula, that is 0 in mass, 1 in length, and 2 in time, isn't it? Now we are discussing about the equations of motion. Equations of motion. Now what is equations of motion means when object is moving with a uniform acceleration along the horizontal direction. When object is moving along the horizontal direction with a uniform acceleration, at that moment it obeys the four equations. That equations we can call it is equations of motion. That four equations I am writing here. V equal to u plus at, and second equation S is equal to ut plus of at square, and third equation it is v square minus u square is equal to 2as, and fourth one is Sn is equal to u plus a by 2n minus 1. In these situations here fourth equation n I given. Here n is nothing but in a particular time interval, in a nth second, the displacement of the particle if you want to calculate, we can use the fourth equation of motion. For example, one object is, for your understanding I am telling this one, when object is here only, one object is traveling from 1 second to 6 seconds, 1 second to 6 seconds. Each and every second, this vehicle covers some displacement. Each and every second, this vehicle covers some displacement. For example, 5th second, what is the displacement covered by the particle? If you want to calculate, we have to use the 4th equation of the motion. At a particular time interval, at any instant, the displacement of the particle, if you want to calculate, we have to use the 4th equation of the motion. And second equation of the motion means the duration of the time. See here, I told you, particle is traveling from 1 second to 6 seconds. What is the distance traveled by the vehicle in 6 seconds? In 6 seconds, that we can use it is, we can calculate by using of the second equation of the motion. That is the difference between the second and 4th equation, isn't it? And in this situation, v is the final velocity, u is the initial velocity, a is acceleration, v is equal to final velocity of the body, final velocity, u is equal to initial velocity, u is initial velocity, and a is equal to acceleration, a is acceleration, and t is equal to time, and we can write it is, next one it is s. S is equal to distance or displacement, distance or displacement. You can write here velocity mean velocity or speed, final velocity or final speed, or initial velocity or initial speed, isn't it? So these equations we can prove by using of the graphical representation. When object is moving with a uniform acceleration on the horizontal direction, it obeys the 4 equations of motion. That equations are is called equations of motion, isn't it? In that one, we have to prove that equations by using of the graphical representation. That equations we have to prove by using of the graphical representation. Now I am writing, on the x-axis I am taking time, on the y-axis I am taking velocity. On the y-axis is the velocity, x-axis is the time I am taking. Now this graph it is, the object is started with a velocity is the u. Object is started when time is equal to 0. When time is equal to 0, the initial velocity of the object is u. Initial velocity of the object is u at a position. Initial velocity of the object is u. At a time is equal to t time interval. When it reaches the time t, it attains the velocity is v. It attains the velocity is v. I am writing this is nothing but a c position, isn't it? When object reaches the position B, it attains the final velocity is v after t time interval, isn't it? Now I am taking this slope, just I am using this slope. What is the slope equation? You know, everyone know where will slope equation is nothing but a tan theta. That only know, slope is nothing but a tan theta. Here just we are writing it is for your understanding, slope is nothing but a I am writing. Why I am writing a, just I will tell you very clearly. Slope is nothing but a. Slope is equal to what you can write, difference between the any 2 points on y-axis. Difference between the 2 points on the y-axis divided by difference between the 2 points on the x-axis. That we can write as a y2 minus y1 divided by x2 minus x1. y2 minus y1 divided by x2 minus x1. Now here y2 minus y1 means I am taking any 2 points. This is one position and this is one more point. A and B are the 2 points. Now A position on the y-axis is nothing but a velocity is u, and B position on the y-axis is v. So here y2 is equal to v and y1 is equal to u. Here this is y2 position, y2 is nothing but a v, y1 is nothing but a initial position is the u, and x2 minus x1. Here x2 is equal to final position x2. What is the time interval? It is the t. So that is the time t, and this is the initial position x1. It is on the x-axis is the origin, so time is equal to 0. x1 is equal to 0. Okay. Slope is nothing but a difference between the 2 points on the y-axis divided by difference between the 2 points on the x-axis, y2 minus y1 divided by x2 minus x1. Here those values if you substituted here, we can get y2 minus y1, v minus u divided by x2 is the t minus 0, v minus u by t, v minus u by t is called acceleration. Just now only we discussed what is acceleration. Change in velocity per unit time interval. Change in velocity per unit time interval is called acceleration. So the slope is acceleration. A I am writing. So A is equal to v minus u by t. Now t if you take this side, A t is equal to v minus u. A t is equal to v minus u. U if you take this side, you can write final velocity v is equal to u plus at. V equal to final, v is nothing but a final velocity, u is equal to initial velocity, and a is the acceleration, t is the time. This is the first equations of motion. It is the first equations of motion, isn't it? And how we can write the second equation of the motion? Second equation of the motion, to find out this one, we have to calculate area under the curve. Area under the curve means area under this curve we have to calculate. Area under this curve. In this situation, you can observe, see here, area under the curve, this is one rectangle. One rectangle is there, one more it is the triangle is there. So, area of the triangle plus area of the rectangle we are writing. Area under the curve. Area under the curve. Area under the curve is equal to, area under the curve is equal to, we are writing it is area of rectangle plus area of triangle. Area of triangle. Now what about the area of the rectangle? It is nothing but a length into breadth. It is nothing but a length into breadth. Now I am writing here, this is the length and this is the breadth if I am taking. See here? Okay, OD. So in this situation, O is the initial position, D is the final position. O is the initial position, D is the final position. So D minus O if you taken, so final position minus initial position. Here final position is nothing but a T, initial position is the O. So area, rectangle is nothing but, otherwise I am writing it is length into breadth like this, plus area of the triangle it is half into base into height. Half into base into height. Now length is equal to D minus O. D minus O means T minus 0. Length is nothing but a T minus 0 and breadth is nothing but a, this is the breadth, it represents like this. Final position is U, initial position is 0. So U minus 0, because T equal to 0. So U minus 0. I am writing breadth is nothing but a U minus 0. So plus U minus 0 plus half into base into height. Now I am writing half 1 by 2. Base is base of the triangle. So base of the triangle is this one. This is the base of the triangle. So coming to the x-axis like this. So this is the final position. D is the final position. O is the initial position. D is nothing but a, what about time? T. And O is nothing but a, time T is equal to 0. Final position minus initial position. T minus 0. And height of the triangle. This is the height of the triangle. See here? This is the height of the triangle in this one. This is the height of the triangle, isn't it? So height of the triangle, just I am moving towards the y-axis because it is parallel to the y-axis. So when you move like this, this is the final position and this is the initial position. Final position minus, that is final minus initial. Here final is nothing but a final velocity. Initial is nothing but a initial velocity u. Final velocity minus initial velocity v minus u. Height is the v minus u. We can write here t u plus half v minus u, t minus 0 is the t, isn't it? Area under the curve we are writing, okay. First u into t, ut I am writing plus v minus u. See here, from this equation, just I am writing, this is equation number 1. This is equation number 1 and it is equation number 2. From the equation 1, v minus u is equal to at is there. So this is equation number 2. If you taken, substitute equation 2 in equation 1. Substitute equation 2 in equation 1. So u into t, u into 2 plus 1 by 2. 1 by 2. V minus u is equal to at. So a t into t, that is equal to ut plus of t into t square of at square. But what about the resultant? What about that? Just I given area under the curve is equal to ut plus of at square. Ut plus of at square we have written. But the resultant is equal to means, see in this situation area of the triangle means y-axis into x-axis. Y-axis into x-axis. Area of the triangle also we are writing y-axis. Base is nothing but a x-axis. Base of the triangle is the x-axis. Height of the triangle it is the y-axis. So x-axis into y-axis. What is the y-axis here? Velocity, and x-axis is the time. Velocity into time is called displacement. Velocity into time is called displacement. So area under the curve means you can write that is the displacement S, isn't it? So S is equal to you can write ut plus of at square. S is equal to ut plus of at square. That is equation number 3. Equation number 3. Just we are writing equation number 3. And third one, if you take the third one, what is average velocity is equal to displacement is equal to, otherwise you can write displacement is equal to average velocity into time. Average velocity into time. So displacement symbol is S. Average velocity is equal to u plus initial velocity plus final velocity divided by 2. Yes, we already proved this equation. Average velocity equation is nothing but a v1 plus v2 divided by 2. When unequal speeds, otherwise with a different speeds in equal time interval, when object is covering with a different speeds, equal time interval, at that moment average velocity is equal to v1 plus v2 divided by 2. We proved already. So v1 is nothing but a u, initial velocity is u, final velocity is v divided by 2. How it can means, in the graph initial velocity is u, final velocity is v. From the graph only just I am taking initial velocity is u, final velocity v. This initial to final, how much time taken it is? 0 to t time interval. So equal time interval we taken. From that one, average velocity is equal to u plus v divided by 2, and time, this is time. Now I am taking, this is equation number 3. From the equation 1, see here, from equation 1, at is equal to v minus u. At is equal to v minus u. Just I am writing from equation 1. Here t is equal to, you can write v minus u divided by a. Just from the equation 1. A, if I take this side, t is equal to v minus u by a. So t is equal to v minus a. Substitute this equation number 4 in 3. Substitute equation number 4 in equation 3. S is equal to u plus v divided by 2, and time is nothing but a v minus u divided by a. V minus u divided by a. See here, this equation a plus b into a minus b. A plus b into a minus b. What is the for resultant? A square minus b square. That equation we can write v square minus u square divided by 2a. 2a, if you bring in this side, 2a s is equal to v square minus u square. This is the third equation of motion. It is the third equation of motion. V square minus u square divided equal to 2a s. This equation we can write like this: a plus b into a minus b is equal to a square minus b square. From this equation, I have written this one. It is nothing but a v square minus u square. Now again I am giving conclusion here. When object is moving with a uniform acceleration, it obeys the 4 equations of motion. That equations only we can call it is equations of motion. In that one, 3 equations are we can prove by using of the graphical representation, isn't it? So first we are taking the slope. By using of the slope, I proved it is the first equation of motion, v equal to u plus at. And second equation, how I proved means area under the curve. Second equation is nothing but a area under the curve. That equation is s is equal to ut plus half at square. That is the second equation of motion. Third equation, simply we have written displacement is equal to velocity into time. But here instead of the velocity I taken average velocity. Average velocity. What is average velocity? v1 plus v2 divided by 2. Here v1 is nothing but a initial velocity, v2 is the final velocity and divided by 2 and into time. This time is equal from equation 1 I taken from this is the equation 1 v minus u a if I taken RHS at that moment t equal to v minus u divided by a. So equation 4 if we substitute in equation 3 we can get u plus v divided by 2 v minus u divided by a. This is we can write as a by using of this equation finally we can get 2as is equal to v square minus u square, that is equation number 5. So these three are the 3 equations we proved by using of the graphical representation.